That's weird. I don't know why that's showing blank. Let me close it and start again. I actually have the outline sitting there. Yeah, I don't know what that was about. Okay, something must have froze. So there's an exam this week on Friday. It's in two parts. There's a take-home portion, which I will put up sometime probably today or tomorrow. I want to put it up tonight. It's already made, so I just have to put it up. And it's due Sunday night, February 6th at 11:59 p.m. You can print it or you can just number regular paper, lined paper, and work the problems out. It's up to you. And this is everything that would be on it. There's 9 questions and it's worth 50 points. But the questions have more than one part to them. Oh, and this outline is on As You Learn for the weekly checklist. If you click on the left weekly checklist, it's right here. And I guess we'll go over this. The attendance for Monday and Wednesday needs to be completed by Thursday. It's early this week simply because if we go over here and go down to attendance, what it's doing, normally I have, when you open your test, you have to write this or sign that you read it. And so this way we don't have to take up that time. We can just take the test. So I want these done by Thursday night, so before the exam. It just, well, you can read it. Just trying to think if there was something I wanted to. I've had times where people are online and they're talking to somebody and you can't talk to anyone. But I didn't worry too much because they didn't pass the exam, so it didn't matter. But so this needs to be done by Thursday night. And it's under, you just click on attendance. Go back to the weekly checklist. The in-class part of the exam is on Friday during class hours. So just like you logged in now, you'll log in on Friday and you'll be able, I'll give you the password and then you'll open the exam and you can take the exam. The exam will be, here it says exams and final. It will be in here. So under dates of exams, it'll have exam 1 in-class portion, exam 1 take-home portion. Any questions so far? So under the weekly checklist, that's where we'll find this paper. And then like today we're recording. I have 2 classes today. Their videos from today will be there. And then Wednesdays will be there. So the take-home has 9 questions and the in-class portion has 6 questions. Any questions? The My Math Labs problems that they are most similar to the in-class portion would be these, and the take-home portion would be these. So like in 1.3, the take-home portion, 8, 11, and 12B, those are good ones to study. And what you can do, and we'll actually use my MATLabs, but you can go on, you can do the problem, and then you can click try another, and it'll let you do another one. It changes the numbers, and then you can try another one until you're comfortable with it. And I think that's the best way to study. 1.4, number 6, and then these ones for the take-home. Some of these are similar, like the horizontal and vertical lines. They're in a couple different ones, even though there's only one question on the test. But I wanted to make sure you knew every possibility. 2.1, 2.2. This is probably supposed to be 2.3. 2, 3, 3, 4, 9. Yeah, this is 2.3. So what I was thinking is we will go through the in-class portion first. Hopefully we'll get through it all today. And then on Wednesday, the exam will already be up for the take home, so you could look at it and see where you have questions. If there's any questions on it, I'll take that first. And then if there's not, then we'll go through as much as we can from these. So maybe even look through these and see which ones you have questions on, and we'll do those. But I want to try and get through all of these today. Any questions? You can have a formula sheet. And a calculator. Pencils. The take home and the in-class portion, you can write out on paper. You don't need to print either one of them. And then you can take pictures or scan it just like you do your attendance. Everything I can. Any questions? When you are taking the exam, you cannot leave the room until your exam is submitted. So make sure you go to the restroom beforehand, make sure you have chargers, and make sure it is submitted before you leave the room. So don't log off of WebEx until you have submitted your exam. There were instructors in a meeting we went to, and students said they forgot to submit, and then an hour later 2 people turned them in, and a lot of the stuff was corresponding together. So it wasn't that they forgot, it was that they cheated. So it has to be submitted before you leave. If you're not sure, send me a little text, did it submit? Or just email me all your answers also as a backup. Any questions on that? So the first one was 1.4. 1.4, number 6. You could also print these. I like having them printed and working them out. And then you can go back and type your answers in at a later date. So then you wouldn't have to keep your computer open. A company finds it can produce 20 heaters at 6,100 while producing 30 heaters at 8,000. Express the cost Y as a linear function of the number of heaters X. So they want us to find the equation. What they're doing is giving us 2 points. Now on the test, I asked for marginal cost, and then I asked for the cost equation. Kind of combined a couple together. Marginal means if it's linear, it's the slope. So this is what you should get for your slope. Twenty heaters, X is the number of heaters. 20 is 6,100, and 30 is 8,800. So those were 2 points that they gave us, because X is heaters, Y is cost. Marginal cost is the slope. Y2 minus Y1 over X2 minus X1. That's a formula that you could write. And also, when it's linear, marginal cost is the slope, which is also average rate of change. So 8,800 minus 6,100 over 30 minus I looked at the answers in the back, should get 270, but there are some problems where you need to explain the slope. Remember, slope is change in Y, and Y is cost, over the change in X, which is the number of heaters. Each additional heater, the cost goes up by 270. So if you need to explain it, your X value goes up by 1, and your Y value goes up by your slope. Any questions on that? To find the cost function or equation, you can use C of X or you could use Y. But the formula is Y minus Y1 equals M times X minus X1. Another formula you can add to your sheet. So when we want to write the equation in line, we need a point and a slope. Well, we found the slope, that was 270. And we can use either one of the 2 points. Well, I'm going to go with smaller numbers, so I'm going to use the first one. But whichever one you use, you'll get the same answer. Y minus 6,100 equals M times X minus 20. Distribute your 270. Any questions so far? Add the 61 to your other side. So marginal cost is the slope. The cost equation or cost function would be this. Any questions on that? Section 2.1. 6 and 11. The profit from the production and sale of hats is given by P of X equals 20X minus 4,000. X is the number of hats produced and sold. And of course, P of X is profit. If it doesn't say units, then it's dollars. Producing and selling how many hats will give a profit of 6,000? We're looking for the number of hats and we want a profit of 6,000. So this would go in for profit. So you want to be able to, when you're given these, know where to plug it in. I plugged it here because it was profit and X is number of hats, which is what it's looking for. Add the 4,000 to the other side. So 500 hats will give a profit of $6,000. Questions? How many hats must be produced and sold to avoid a loss? To avoid a loss, that is the same as break even. So if you're asked for the break-even quantity or how much is needed to avoid a loss, you either set profit equal to 0, in this case we have profit, or if you have revenue and cost, you set them equal. In the next chapter, we'll learn that profit is revenue minus cost. But for right now, so either one of those, depending on what you're given. In your homework assignment on Friday, you were given revenue and costs, and so you needed to set them equal and solve. For this one, though, we're given profit, so we set profit equal to 0 and solve. Add the 4,000 to the other side. and divide by 20. Questions on that? What that means is you're not making any money until you sell 200 hats. So you're still in the hole or owe money until there's 200 hats sold. Break-even quantity is where you start making money. So after 200, you'll start seeing a profit or you'll avoid a loss. Any questions on that? This is another equation that you might want to put in your formula sheet. Questions? Or what? The number of banks in the country for selected years from 1980 to 2009 is given by equals negative 379.1 x plus 18 x is the number of years after 1980 and y is the number of banks. So the first one, the number of banks in the country would be up. Read the question. In what year would the number of banks be 6,306? This is the number of banks, and we said y was the number of banks, so you plug that in for y. And we want to find the year. So first thing we would do is subtract this 18,000 to get x by itself. So we get a negative 12,131. We're still trying to solve for x. Since this is multiplied, we need to divide by the 379.1, and it's a negative 379. So approximately 32 years after 1980, because X was the number of years after 1980. No, they wanted to know what year. So 32 years after 1980, I take 1980 and add 32 years, get 2000. So in 2012, there was 6,306 banks across the United States. Any questions on that? How many banks were there in 2000? Should we plug into X or Y? We look,
The X.
yes, we need to plug into X. But you want to be careful. Most common mistake is to plug the 2000 in. But X is the number of years after 1980. So we need to take the 2000, yeah, and subtract the 1980. So we're actually going to plug in 20 because it's 20 years after 1980. We should get 10,855 banks in the year 2000. Any questions on that? Two point two, number one. And the main thing on this one is, let's see, determine whether the scatter plot on the right might be modeled by a linear function. Well, you can tell it's forming a straight line. So it can be modeled as a linear function. And if it's exactly a straight line, which means if your r squared is 1, then it's an exact linear model. So if r squared equals 1, all the points are on the line. It's called a trend line. And it's an exact model. So if r squared is 1, you have an exact linear model. So there's a question that gives you some parts of it, and then you need to explain. You will not have to graph on Desmos for the in-class portion. You won't use any technology other than your calculator. Any questions? That was the only thing from that one. A lot of the earlier ones are just using the information, like they were the algebra behind the story problem. So most of the in-class comes from the later sections. I think this one is 3, 4, and 9. Section 2.3. A manufacturer of automobile air conditioners has a total revenue of 101.5x and total cost 50.30x plus 5,836.8. X is the number of units produced and sold. First one says, using a non-graphical method, find the number of units needed for the manufacturer to break even. Remember, break even is also making sure you're not at a loss. And you set your revenue equal to your cost. You're not at a loss if what you bring in is the same as what went out. And that's why you set them equal. So if we had profit, we would set it equal to 0. Since we don't, we set revenue equal to cost. So we subtract, to get the x's together, we'll subtract the 50.3. Divide by the 51.2 to get x by itself. So you need to sell 114 units to break even so that you are not at a loss. After 114 units is when you start making money. Any questions on that? I wrote some notes on the side, other questions that I asked. So the revenue when 20 units are sold. Well, revenue means we're using the revenue equation. Should we plug in for X or R of X? So the revenue tells us to use this equation, then we have to decide whether to put in for X or Y. 20,
X.
yes. 20 units, X is units, exactly. Plug in for X. So R of 20, 101.5 times 20. So if we sell 20 units, will bring in a revenue of $2,030. How many units can be produced when the cost is $16,400? Whenever you're talking about produced, you're automatically talking about your cost. Then that's this equation. This equation, we need to decide if we plug in for X or for Y. So if we have $16,400, dollars is our cost, X is units. So it has to go in for the Y value. And then you solve for subtract the 5,836 to the other side. And then we divide by the 50.3 because we need to get X by itself. When you're talking about cost and you're rounding, even if this was 0.9, you don't have enough to finish it because you only have the 16,400. So this is a case where no matter what the decimal is, you drop it off. You cannot round up. You don't have enough money to finish it. So it would be 210 units. Now, profit and revenue, in order to hit that value, would have had to round this up. So working with revenue and profit, you have to round up to the whole number. Cost, you have to drop the decimal. Any questions? That was everything on that one. Number 4. The demand for a certain product is given by P plus 4Q equals 380. And the supply for this product is given by P minus 8Q equals 8, where P is the price and Q is the number of products. Find the price at which the quantity demand equals the quantity supplied. So that means where demand and supply are equal. I could also say find the equilibrium point, which is what I did. So instead of asking it this way, it'll say find the equilibrium point. That's where your supply and your demand are equal. when you have two equations, we could solve it. You won't be able to use Desmos on the in-class portion. So you could solve it by elimination or substitution. I would probably use elimination. But we're gonna have to multiply by something. Would you want to get the P's or the Q's to drop out?
P's.
Okay. So if we were going to get the P's to drop out, um, they're both a 1. What would we have to do?
Negate one.
Make one of them a negative. So we either multiply through by the top or the bottom. I chose the bottom simply, I don't know, I just did. I like my negatives on the bottom. So the top I'm not going to change. The bottom, I'm going to multiply everything by a negative. Now you could have also gotten the Q's to drop off, just multiply the top by 2, and you'd have 8Q and a negative 8Q, which isn't too bad. But Q's drop off gives us 12Q equal to 300. So the quantity is 25. Any questions on that? So the P's dropped out. For the other, you need to plug it in. I'd probably use the first one. P plus 4 times 25 equals 380. So we just plug this in for Q, and you can plug it into either equation, you'll get the exact same answer. So you could double check your work and make sure they're the same. Track the 100 to the other side. So for the equilibrium, we would sell them at $280 each, and we would sell 25 of them. So if we produce 25 and sell them at 280, we will sell all of them. Because our demand and what we supplied was the same. Any questions on that? So equilibrium point, you set your supply and your demand equal to each other or solve for them. Any questions on that? That's all I had on that one. There is one interest problem where you set up the two equations. One equation will be the amount that you're putting into the two accounts. The other one will be the interest that you earn. So we're investing $27,000 into two accounts. One of them, I'm going to let X be the amount at 4%, and Y will be the amount at 10%. So X and Y are the amount of money we're putting into the account. and we're investing $27,000. So that means X plus Y is 27,000. The interest that we make 4% on the amount of money that we put here. Remember, when you're plugging into an equation, you either move your decimal to the left 2 or divide by 100. So the amount of money that this makes is 0.04x. Make this a decimal and then multiply it times x. So that's what this account brings in. This one brings in 10%, which is 0.1 or 0.10 y. And my interest is 2,280. Any questions on that? Now, in order to find out how much is in each account, we need to see where these intersect or solve them. You could solve by substitution or elimination. Any preference?
Substitution, please.
Okay. So I would take the top equation and solve for x or y. I'm going to solve for x by subtracting the y over. Then in the next equation, you want to plug this in for x. So this will go in for x. On the test, on the take-home part, there's one problem, 2 equations, and I have you solve it all 3 ways. On the in-class portion, it's up to you. I don't specify. It just says to solve it. So you can solve it. You can't use graphing, but you can solve it by substitution or elimination. So this way you see both of them. So we're plugging this in 0.04 times. In place of x, I'm putting 27,000 minus y, then plus 0.10y equals 2280. So I just took out the x and put this. Then you solve. In order to solve, you first have to get rid of the parentheses by distributing. Get 1080 minus 0.04y plus 0.10y equals 2280. We could combine our like terms here. Subtract the 1080. And then divide by the 0.06. Any questions? So they asked for how much was put into both accounts. This is only one account. And because I label them, I know which one it is. This was Y, so it was 10%. $2,000 at 10%. To find the other one, you can use either one of the equations. Of course, I'd use the one without all the decimals. X plus Y, which is 20,000, equals the 27. Now this one you can do in your head, but subtract the 20,000. $7,000, and that's X, which is at 4%. Any questions on that? So that's everything that's on the in-class portion. Thing is, you need to know what to use when. You can't be taking time to look for everything. Which you shouldn't be doing anyways, but